GATE 2019 Civil Engineering Set 2 Question 35. The inverse of the matrix 2 3 4, 4 3 1 and 1 2 4 is. Four options are given. The relevant NPTEL reference has been cited. To find the inverse of a matrix, one needs to know the relation that inverse of a matrix is given by the adjoint of the matrix divided by the determinant. If we are given a matrix A, B, C, D, so the determinant is given using the relation where we multiply A into D and we subtract it from B into C. This gives the determinant. If we need to find the adjoint of A, what we need to do is find the cofactor matrix for A and then we take its transpose. So the cofactor matrix of A is found by taking each element and then cancelling out the row and column corresponding to that element, taking the determinant of the remaining elements and substituting it along with the sign convention. So the sign convention of a matrix is given as plus minus minus plus. For a 3 into 3 matrix it is given as plus minus plus, minus plus minus and plus minus plus. So here if we take the first element A, so we will remove its row and its column. So the only element that would remain is D. And the sign convention for the first element is positive. So we will put D here. Then we will take B. We will remove the row and column corresponding to this element. The element that remains is C. So we will put minus C here. Similarly, we will take for C and we will put B here along with a minus sign, and for D we would put A. Taking its transpose, it would give D minus C and minus B A. This will be divided by the determinant that was obtained in this step. So for a 2 cross 2 matrix, the principal diagonal elements are interchanged and the remaining two elements across the secondary diagonal are negated in order to find the inverse of the matrix. In our case, we have been given the matrix A as 2, 3, 4, 4, 3, 1 and 1, 2, 4. So the first step towards finding the inverse is finding the determinant of the matrix. So we will take the first element, that is 2, take the determinant of the remaining, that will be 3 into 4, 12 minus 2. This will be operated again with the second element, that is 3 here. Removing its row and column, we would get 16 minus 1 and plus for the last element, that is 4 in the first row, we would get 4 times 4 into 2, 8 minus 3. This would give the determinant value as 20 minus 45 plus 20. Essentially the determinant will be minus 5 for the matrix A. The second step is the computation of the adjoint of this matrix. So the adjoint, as we saw, is the transpose of the cofactor matrix. So the cofactor matrix is found by removing the row and column corresponding to each element, calculating the determinant of the remaining elements and then substituting that element along with the sign convention. So the sign convention of a 3 cross 3 matrix is plus minus plus, minus plus minus and plus minus plus. This sign convention can also be recalled by the formula minus 1 raised to the power I plus j, where I is the row index and j is the column index. So for the first element 2, we would remove its row and remove its column and find the determinant of the remaining elements, that would be 3 into 4 minus 2 into 1, which would give the value as 10. And the sign convention for the element is 10, so we will put 10 here. Similarly, for the second element 3, we remove the first row and the second column and find the determinant of the remaining elements, that would be 4 into 4 minus 1 into 1. That would give the value as 15. But here the sign is negative, so we will put minus 15. Similarly, we can do for the other elements and we will get the value as minus 4, 4, minus 1, minus 9, 14 and minus 6. We need to take the transpose of this, which would give the matrix as 10 minus 4 minus 9, minus 15, 4, 14, and 5, minus 1, minus 6. So first we computed the cofactor matrix and then interchanged its rows and columns to get the adjoint. The third step will be the calculation of A inverse, that is given by the adjoint of the matrix A divided by its determinant. So we have computed the adjoint here and we know the determinant as minus 5 computed in the first step. So dividing each element of the adjoint matrix by the determinant value, that is minus 5, we would get the inverse as minus 2, 4 over 5, 9 over 5, 3, minus 4 by 5, minus 14 by 5, minus 1, 1 over 5, and 6 by 5. So firstly we need to find the determinant. Secondly, we will find the adjoint, which is the transpose of cofactor matrix, and then we divide the adjoint by determinant to obtain the inverse of the matrix. So the inverse of the matrix 2, 3, 4, 4, 3, 1 and 1, 2, 4 is minus 2, 4 by 5, 9 by 5, 3, minus 4 by 5, minus 14 by 5, and minus 1, 1 by 5, 6 by 5, which is essentially option C. The relevant NPTEL reference has been cited.